Hey there, and welcome back. Today we're diving into a topic that's close to a lot of people's hearts, and honestly one that can be tough to talk about: suicide.
It's definitely a heavy one.
Yeah, but we're not shying away from the hard stuff here. We're going deep into the science, specifically how our brainwaves might hold the key to understanding and maybe even predicting suicide risk.
It's fascinating research.
And to help us navigate this complex world, we have expert speaker here with us. You've been diving into some fascinating research on EEG, brainwave activity, and suicide. Now, I gotta admit, when I first saw EEG and brainwaves, I thought, okay, this is gonna be way over my head.
It can seem like that at first, right?
Yeah, a little bit.
But it's actually pretty intuitive once you get the basics down.
Okay, so maybe you can break it down for us. What exactly is EEG, and how is it being used in suicide research?
So EEG stands for electroencephalography.
Okay, catchy name.
Right.
Yeah.
It's basically a way to listen to your brain's electrical symphony in real time. Imagine your brain is like an orchestra. All these different sections, different instruments working together. EEG lets us pick up on those subtle electrical signals that each part of your brain is sending out.
Okay, that's actually a pretty cool way to think about it, the brain as an orchestra. So with EEG, we're listening to the music of the mind, so to speak. How does that relate to suicide?
Well, researchers have been using a specific type of EEG called quantitative EEG, or key EEG, to compare the brainwave patterns of people at risk for suicide to those who aren't.
So it's like taking a snapshot of those brainwaves and seeing if there are any patterns, any differences that stand out. Wow, that would be incredible to be able to identify those early warning signs. The research you sent actually breaks things down by brainwave type. Can you tell us more about these different types of brainwaves and what they tell us about suicide risk?
Absolutely. Let's start with the slower waves, like delta and theta waves, which are often associated with deep sleep and relaxation.
Okay, so those are the waves we see when someone's really chilled out.
Exactly. But these waves also play a role in decision-making and emotional regulation, especially in the frontal part of the brain.
The frontal part, that's like the brain's control center, right?
Exactly. And the research shows some interesting trends there. For example, one study found that even in young, healthy adults, increased theta activity in the frontal region was linked to suicidal thoughts, even when they didn't have signs of depression or anxiety.
So even if someone seems fine on the surface, there could be these underlying differences in brain activity. That's a little unnerving, honestly. But it also shows how complex this all is. I mean, you're telling me our brains might be sending out SOS signals before we're even consciously aware of feeling suicidal.
That's what the research suggests, and it's part of what makes this field so fascinating and important.
Okay, so we've talked about the slower brain waves, but what about those faster frequencies? The research on beta and gamma waves paints an interesting picture.
They do. Beta and gamma waves are more active when we're alert, focused, or even stressed.
So when our brains are really firing.
Exactly.
Yeah.
One study found that people with a history of suicide attempts had higher beta and gamma activity than those who had only experienced suicidal thoughts.
So that makes sense, right? If you're in a state of intense psychological pain, it makes sense that your brain would be in overdrive.
Exactly. But here's where it gets really interesting. Another study found that weaker synchronization between beta and gamma waves was also linked to suicide attempts.
Okay, so high activity and poor coordination are both red flags.
It seems that way. This could reflect a struggle with emotional regulation and impulse control, which aligns with the idea that suicide is often an attempt to escape unbearable emotional pain.
It's like the brakes aren't working as well when they're needed most. This is heavy stuff, but it's also incredibly eye-opening. Are there other brainwave patterns that researchers are looking at?
There's one more I want to mention: frontal alpha asymmetry, or FAA.
FAA. Okay, can you tell us a little more about what that is and how it fits in?
Absolutely. So to understand FAA, imagine holding a scale in your mind. On one side are positive emotions, the other side negative. FAA is about whether that scale is balanced or tipped heavily in one direction. It looks at the balance of alpha waves. Those are the ones associated with the relaxed yet alert state between the right and left sides of the frontal cortex.
So we're talking about looking at the front of the brain versus the back and seeing if one side is more active than the other.
Precisely. And the research suggests that this balance or imbalance could be a marker for suicide risk.
Okay, I'm starting to see how these subtle shifts in brain activity might provide valuable clues about someone's risk level. This is fascinating, but it's also a lot to take in. Can you tell me, what's the one thing you really want listeners to understand about all of this?
If I had to leave the listener with one key takeaway, is that we may be on the verge of a revolution in how we approach suicide prevention.
A revolution, that's a bold statement.
It is, but I believe it's true. For too long, we've relied on people being able to articulate their struggles, to reach out for help when they're in crisis. But what if we could identify those at risk before a crisis hits? What if we could use these brainwave patterns as a kind of early warning system? That's the potential here.
That's incredible to think about. It's like we're moving from reactive to proactive mental health care. And it sounds like QEEG could be a game changer in that regard. But you mentioned a revolution. What would that look like in practice?
Imagine a world where mental health screenings include a quick and painless EEG, alongside those questionnaires many of us are familiar with. This could help identify subtle brainwave patterns that might indicate a higher risk for suicide, even in individuals who appear fine on the surface.
So someone could be flagged for early intervention even if they haven't consciously acknowledged their struggles or reached a crisis point.
Exactly. This could be particularly life-changing for those who struggle to articulate their emotions or who fear the stigma associated with seeking help. Early intervention is key, and KEEG could provide that crucial window of opportunity.
Okay, so we have this incredible tool, but there's always the question of access. EEG isn't exactly something everyone has lying around in their homes. How do we make this technology available to the people who need it most?
That's the million-dollar question, isn't it? And it's something researchers and policymakers are grappling with right now. One solution could be integrating QEG into existing healthcare systems. Think primary care offices, schools, even workplaces.
So instead of waiting for someone to reach a breaking point, we could potentially identify risk factors during a routine checkup or even at a school health fair. That feels like a huge shift in how we approach mental health care.
Absolutely. It's about normalizing the conversation, removing the stigma, and making these tools as commonplace as, say, checking your blood pressure.
I love that. Taking something that feels very clinical and making it part of our regular wellness routine. Now, I have to ask, with all this talk about brainwaves and prediction, are we suggesting that QEG can tell us with 100% certainty whether someone will attempt suicide?
That's an important question, and the answer is no. No tool can predict human behavior with absolute certainty. What QEG can do is provide valuable insights into brain activity that may increase or decrease someone's risk.
So it's more about understanding the nuances, the individual factors that contribute to someone's overall risk profile.
Precisely. It's not a crystal ball, but it's a powerful lens through which we can view and potentially understand suicide risk in a whole new light.
I think that's an important distinction to make. It's about empowering individuals and healthcare providers with more information, not creating a deterministic view of someone's future.
Exactly. And it's important to remember that this research is ongoing. We're still in the early stages of understanding how these brainwave patterns relate to suicide risk.
That makes sense. Like any scientific field, there's always more to learn and discover. But even in these early stages, the potential feels huge. We've talked a lot about QEG and its potential for suicide prevention, but what about intervention? Can this technology help people who are currently struggling with suicidal thoughts?
It's an area of active research, and there are some promising avenues. For example, a type of therapy called neurofeedback uses EEG to train individuals to modify their brainwave patterns in real time.
So it's like going to the gym for your brain. You're actually working out those neural pathways.
Exactly. And early research suggests that neurofeedback might be helpful in reducing suicidal thoughts and behaviors.
Wow, that's amazing. So instead of just talking about our problems, we could potentially retrain our brains to respond differently to those difficult emotions.
It's an exciting possibility, and one that highlights the incredible plasticity of the human brain.
It's like our brains are capable of so much more than we often give them credit for.
That's a great point. And I think this research really underscores the importance of hope. Even in the face of something as devastating as suicide, there's always hope for healing, for change, for a brighter future.
That's a powerful message, and one I think we all need to hear sometimes. Speaking of hope, the research you shared did mention some particularly intriguing findings about a specific brainwave pattern and its connection to suicide risk.
You're talking about the research on frontal alpha asymmetry, right?
Yes. Can you refresh our memory on what FAA is and what the research found?
You got it, FAA, the Brainwave Balancing Act.
Right, FAA.
We were talking about how the balance of alpha waves in the front of the brain might be different for people at risk of suicide.
Yeah, like is one side more active? Is it tilted in one direction or the other? That kind of thing.
Exactly. And here's where it gets even more interesting. The research found that this pattern of asymmetry, whether the left or right side is more active, might actually be different depending on whether someone is also experiencing depression.
Okay, so we're talking about two different scenarios here. Suicidal thoughts with depression and suicidal thoughts without depression. What did the research show?
Well, they found that people with major depressive disorder and suicidal thoughts tended to have higher alpha activity on the left side of their frontal cortex compared to those who weren't depressed. But here's the kicker. Individuals who had suicidal thoughts but weren't depressed actually showed the opposite pattern, higher activity on the right side.
Wow, so the brain activity is totally flipped depending on whether depression is involved. That feels like a huge clue for researchers.
It is. It suggests that suicidal thoughts might arise from totally different brain mechanisms depending on the presence or absence of depression.
Which makes sense. I mean, it's not like there's one single path that leads to suicidal thoughts. Everyone's experience is different, and their brain activity likely reflects that.
Precisely. And this is where understanding your own experiences and sharing them with researchers and clinicians becomes invaluable.
You know, it's interesting you mentioned in your notes that you sometimes feel like you're on autopilot, like you're just going through the motions, even when you're feeling really low. Do you think that experience could be connected to these brainwave patterns we've been discussing?
It's certainly possible. The research on reduced beta and gamma activity in the right temporal region, which is involved in things like emotional processing and memory, is particularly relevant here.
Right. You said that lower activity in this area was linked to an increased risk of moving from suicidal thoughts to actual attempts.
Exactly. And this particular study focused specifically on women with major depressive disorder, which is interesting given your own experiences. It really highlights the need for more research on how these brainwave patterns might differ between genders and across different demographics.
Absolutely. We need to make sure we're representing everyone in this research. Okay, so we've covered a lot of ground here. We've talked about different brainwave patterns, their potential link to suicide risk, and the possibility of using this technology for both prediction and intervention. It's a lot to process. As we wrap up, what's the one thing you want our listener to take away from this deep dive?
I think the most important takeaway is that there's hope. We're on the cusp of a new era in mental health care, one where we can potentially understand and address suicide risk in a far more nuanced and proactive way. It's not about predicting the future, but about providing individuals and their care teams with more information, more tools, and ultimately, more hope.
I love that. More hope. It's been an incredible deep dive. Expert speaker, thank you so much for guiding us through this complex and important topic.
My pleasure. It's been great being here.
And to our listener, if this conversation has brought up any difficult emotions, or if you're concerned about yourself or someone you know, please know that you're not alone. There are resources available to help. You can find some of those resources in our show notes. Until next time, keep exploring, keep learning, and take care of yourselves.